Let's see, today is February 25th. It's noon Pacific time. We have Eric Dollard live on the call here. Last call we did was, about 2 weeks ago. I think it was February 4th. And that video is of the recording is on my YouTube channel, YouTube/Aaron Murakami or Aaron Murakami 13. I can't remember which one. But it's in the blog post. If you go to emediapress.com, in the main menu bar, there's a blog link. And if you click that, that's where I post any of the updates. And I would recommend anybody sign up for Energy Times, because that's kind of the main place where I announce any of these calls or any updates. I'll type the link in the chat bar here. That's the main newsletter right there. And so I think we'll have, normally Griffin Brock joins us on these calls, at least the last few on Zoom. And he's not going to be able to make it with us today, but Haka says we'll be giving some updates on what him and Griffin have been involved with. And I think Adrian might have some stuff to contribute, and possibly even Bruce Gavin, who I see is on the call, who's the one that built the Colorado Springs replica for the 2019 presentation. And he was on the call last time as well. EPD Labs, EPD Laboratories, Inc. is a 501c3 nonprofit corporation, and it's solely funded by donations. And the primary website for that is ericpdollard.com. And we had to use a different template because we had to upgrade PHP, which is kind of like this little program deal on the server. And there were some issues with the other template that we had on there. And so it's an updated template. So this time, when you go to ericpdollard.com, if you scroll down, it'll actually be in the left column where all the donate information is. Or you can go to ericpdollard.com/donations, which I'll type in here. It's either donation or donations, and that'll take you to a dedicated little page with the donation link. Is there any, what do you want to start with, Eric?
I guess I can start with what we got done here in this last episode.
Okay.
Like the upcoming presentation.
Okay, and the paperback is available on Amazon, and I can give a link to that after.
Okay.
So, yeah. So the Eric will be coming up to do a presentation, coming up to Spokane to do a presentation, which is the 12th annual Energy Science and Technology Conference. That'll be July 5th through the 9th. You can go to energyscienceconference.com for details on that. And the tickets are available on emediapress.com. If you go to emediapress.com and scroll down, the first thing at the top will be an advertisement for the conference. And then there's a link you can click, which will take you to a page with two buttons. One button is for the live streaming tickets, and one is for the in-person tickets. We're limiting it to 65 people in person, and 25% of all the tickets sold out within just the first couple days that I announced it. So if you want to come to the conference, it's time to get the tickets. I'd recommend getting them right away. That's not a fear or loss thing. These tickets sell out every single year, and they sell out pretty fast. So Eric will cover the presentation that he's going to be doing, which I think is going to be one of the afternoons. Normally we do the Eric's presentations in the morning before lunch, but his primary solo presentation will be the first one right after lunch, and that'll be, I believe it's on a Thursday or a Friday, and I can post a link to that schedule. So you want to go ahead and touch on what you wanted to cover with the presentation, Eric?
Okay, so the title has been decided upon. It's the History, Theory, and Practice of Four-Phase Systems. And it gets pretty deep into how Tesla conceived all this and how it was implemented by Westinghouse. And also it has a musical component because polyphase is also polyphony, which basically began in around the 16th century. So I'm going to get into the musical as well as the electrical and the mathematical end of all this. So it's been rather difficult. There never really has been a detailed polyphase mathematical analysis of force phase, and it's kind of been running me ragged because with three phase, you only have three sequences. You have positive sequence, which means you're rotating clockwise, and you have negative sequence, which means you're rotating clockwise, and then you have zero sequence, which does not rotate but flows through the neutral. With four phase, there's another sequence called the alternate sequence, and this has never really been developed at all because four phase doesn't really get used too much anymore. And that's been quite a workout, but I think I finally broke through, and now it's all fitting together. So I'm drawing up the final drawings for all this. It's going to be quite an extensive presentation. The main snag right now is I don't have anybody to do the musical part. So I don't know who's going to play all the sequences and components for me and get it recorded. But at any rate, I'll still put that together here, but I don't know how I'm going to get that out.
So Eric, yeah, I contacted St. John's Cathedral about their getting in touch with their organist. I did not get a response yet, but I did find that there is some kind of national guild of organists. I think it's based out of New York or something. And so I can pass on the contact information to see if there's, anybody here in the Northwest. But I think during sometime in April, I think we can get a hold of somebody local. St. John Cathedral is only, the main big Gothic church here in town that has a real organ in it. But I think there's a few other churches that do too. So I don't think it'll be too hard to find somebody.
Yeah, it'll probably work out. So the piece of music that represents four phase is Bach's Prelude and Fugue in A major. The fugue is very four phase. I haven't yet broken it down, but probably in about a week I'll have all the polyphase diagrams done and I'll be ready to start on the music. And I'm quite really excited about what this is going to sound like when I take it apart, because it's a very interesting piece of music. The work episode here was very productive. Of course, it was also very expensive, about $7,500 total for my savings from my fixed income. And then there was a substantial donation of these calls ago, $5,000. So we kind of had to, because of the complete lack of cooperation and the non-functionability of society in general, it's been very difficult to try to move forward on this project. It's supposed to be centered around the seismograph mine, but the expense of that and trying to get estimates and what have you has been so difficult that we decided to focus on the cable TV shack at the end of the 2.2 mile long line and get that all together. So basically the building itself is pretty much wrapped up. The rat proofing and RF shielding screen has been installed. The walls are all put up. The framing's all done. The ceiling's done. The terminal pole has all the mounts for the VHF antennas, and then we put up a mast for one of the auxiliary VHF antennas and a possible radio link out. So the next step now is to assemble the racks that go in the cable TV shack and do all the wiring, the coax and ground leads and what have you from the antennas and the weather box and all those type of things. And then the third step is to put up the antenna, the Alexanderson Beverage antenna section, which goes from pole 26 to pole 56, which is the terminal pole, the cable TV shack. And actually it goes from pole 26 to pole 48. And then transmission line goes to pole 56 in the cable TV shack. So we got to drop one more pole, and we're missing one. The rest of the line has pretty much all been refurbished, cross arms are up and all that kind of stuff. So we'll basically be putting up a 4,800 foot antenna section, and then the remaining section will be the transmission line of the shack. That will receive out of the Earth ionosphere electrostatic capacity, which I found is very responsive to major earthquakes around the world. And then quite possibly, even though this is not the route that I want to go, but we're having to kind of cut corners, is to establish some kind of temporary internet type of radio link to a place where then we can get these received signals on the internet. And then I think that basically represents one level of completion in this project. That's about the best we can do. The tragedy is we cannot get the seismographs hooked up, which is very disturbing, because the result of that would be quite fantastic. No one has ever really done an audio frequency translation, and nothing is really available right now that has a sensitivity of what we have, but that doesn't seem to be moving forward. So basically 2 more episodes, but the problem is right now is I don't have any more savings, and where to get the money from to do this. It's mostly labor costs at this point. Big material expenses are over. So we'll see. We'll see how it works. But May is when we all want to get together and put the Beveridge Alexanderson antenna up, finish the telluric test platform, and quite possibly have another Tesla transformer configured to start doing some experiments. So because we're not really getting anywhere with the HF end of this, I've decided probably the best thing to do at this point, if time and resources allow, is to build a 60 kilocycle coil, because this stuff's all basically supposed to be working down in the Alexanderson band, which goes from 10 to 30 kilocycles. 60's close. Colorado Springs was 45, if I remember right, or somewhere around there. Marconi and Bolinas was 44. So there is a National Bureau of Standards transmitter in Fort Collins, Colorado, that transmits on 60 kilocycles. It's called WWVL. So I think the test will be to see at what strength we can get that signal out of the ground. The ground system's all complete now. The tanks are all welded up. The leads are put in. The poles for the platform and the overhead is all done. So basically, I think Griffin and Hackas's will be assisting me on that, and then Justin and myself will be dealing with the Alexanderson Beveridge antenna and the racks in the May episode, and then there'll probably have to be one more episode in the fall to try to get this thing on the internet in some level, so you can listen to what the signals sound like. So I think that's pretty much it for here.
Okay, I'm just pulling up the Amazon book here. Let me show that here in just a second. So in the chat, okay, so you want me to go into the book real quick?
Yeah.
Okay, so on February 4th, when we did the last call, we went more in depth on the book. I showed a screen view of the table of contents, so I don't think that's necessary to go into. The ebooks are part 1 and part 2, electromagnetic induction and its propagation, which is an extension to Heaviside's work of the same title, part 1 and part 2. Both are available as downloads on emediapress.com right now. If you get both, it's available at a discount. On Amazon, it's available as a Kindle download. And finally, the paperback's available. I just posted a link inside of the group chat here. If anybody clicks that, it'll take them straight to the Amazon page. And let me do a screen share real quick of the actual book on Amazon. Just give me a second here.
Now I got something. Yeah,
Okay.
the other page.
Okay, so this is the part 2 paperback on Amazon. Part 1, I think if you scroll down, or basically if you just click Eric's name here where it says author, you can find part 1 as well. I'll do that real quick. So yeah, so if you click on Eric's name under the author, you can scroll down and you can see the paperback is here on Amazon as well. That one is $17.95. This current book is $26.95. For one, it's color. That's why it's a little more expensive, but it's also 3 times as big. This thing is almost, it's like 200 pages about or so. And so anyway, that's brand new. That's available. If you happen to be coming to the conference, I'll probably have a box of 50 books, and I'm sure Eric will be happy to sign it for you if you want to come up here and meet us all in person. Let's see, besides the book, let me share the conference schedule real quick. This is updated a little bit from last time, so you can see the link here. I'm gonna post this in Zoom again real quick. Actually, I'll do that here in a second. Basically, energyscienceconference.com, and that has all the details. And if you click on 2023 conference schedule, it'll bring you to this page, July 5th through 9th, Wednesday through Sunday. And let's see, here's the Wednesday, Thursday, Friday. So on the Friday schedule, July 7th, Hakases has a 90-minute presentation in the morning with a demonstration. We'll post the presentation title and all that here soon. Then there'll be a 15-minute break, and then Griffin will be giving a 2-hour presentation. The Tesla radiant matter tube and related phenomena. There's a post on Eric's page dealing with on the front of it, dealing with the shadow graph type experiments, and that's going to be related to this presentation. And I think on griffinggbrock.com, he has some other possibly identical blog posts showing those experiments. And then right after lunch, Eric I have for right now 4 hours. It could be 2 hours, 3 hours. I just blocked off 4 hours. We'll just kind of make it up as we go along, as we get closer to the conference. And that's the presentation that Eric just described a minute ago. And then after that, I'm just blocking off an hour and a half right now, which Eric and I will do a presentation on the audio bay, which was also, we went into more depth on that on the last call, which you can see the video either on YouTube or on emediapress.com of the last Zoom call, where I showed a bunch of pictures of it. And in April, that'll be one of the priorities is for Eric and I, and I'm sure Dr. Adrian Marsh will be helping out to get that finished and tested, and he'll be working on some projects as well. Let's see, Hakases, do you want me to let Eric, do you want me to let Hakases go into some of the updates with Griffin that Griffin wanted to cover since he's not here?
Yeah.
Okay, let me stop this screen share real quick. Bring on let's see. Go ahead, Hakases.
You got me okay? Okay.
Yeah, I'm trying to get, okay, there you are. Yeah, go for it.
See while I start up, see if you can get me screen share permission, and I can post some of the pictures. So the latest update, about a couple of weeks ago, I was lucky enough to have a free weekend, so I actually went up to Griffin's shop, and we were able to collaborate quite a bit and do some of the experiments with the radiant matter bulbs that he's been building. So the primary goals we had of that was to see if we could replicate the effects of the bulb without using the diathermy machine, which he has in his possession, which is a very old 1930s electronic Tesla coil, predating all the other stuff. But it would be very hard to mass replicate this stuff. We wanted to make sure we could do the same effect using normal equipment. So secondary goal is I happen to have the equipment to do a tiny cloud chamber experiment I wasn't even sure if it would actually work, but we were lucky enough to get that going. So first on here, if I can do is share, I can post some pictures. Or maybe still working on that. Griffin's update, since his thing, he's been working on creating a prototype or a standardized bulb configuration, a 1A21, and doing some various experiments with both range propagation and the shadow graph field characterization, the direction and scatter. Mine, since then, we were able to get some success using the equipment that I brought over to get the machine running. So my test following the shop visit has been trying to basically reproduce some of the same stuff. I still can't. Could you try doing a screen share? Or
It'll show my screen. I'm in Zoom trying to set you up with access to that. Yeah, it looks like that's something that has to be set up for a user before the call. But if you can, in that private chat there, if you can type me the email you use to log into this thing, I'm going to see if I can make those permissions live while we're on the call.
Okay. Yeah, sorry, it's a little bit scattered here too.
Yeah, got it.
So just going over the rough, when I was over at the shop, we were able to fire up. We tried 3 different setups to see if the Griffin's shadow graph bulbs would function. The first was a standard HF radio amplifier configured as the Tesla coil configuration that we showed in last year's presentations. That did not work. We suspect it was primarily due to the critical voltage that was required to get the effects. The bulbs would light up with a little bit of blue, and sometimes they would arc over internally, but basically it wouldn't produce any shadow graph, and it wouldn't trigger anything on the Geiger counters. So the next one we tried was a vacuum tube Tesla coil, which I believe Griffin actually presented one 2 or 3 years prior, but it's a Armstrong oscillator driven vacuum tube. I think it was about 500 watts. Same issue though, where the voltage was quite low, probably less than 20 kV, and the bulbs would barely light up, very tiny result, but we were able to get something with that. And then the primary one was using a what's considered a disruptive discharge Tesla coil, using a 12 kilovolt neon sign transformer that I had brought. And with that, we did have the best results, and we actually did get some shadow graph bulb results using that, which is functionally equivalent to what Griffin has on the diathermy machine. So at least we do have a method of reliably replicating this. Since I got back, I've been trying to get that, not just get results, but also improve the character and quality of it. One of the things we're finding is that while there is a critical voltage, it does seem to require some portions of current as well. The neon sign is only 12 kV, 30 milliamps, so a few hundred watts, but the current is very low. So despite being cold cathode, it does seem like it requires some additional kick to get going. Because I think Griffin's was closer to 100 or 200 milliamps at a much lower voltage, I think 4 to 5 kilovolts. What else? I was also able to see some of the glass blowing stuff that he did personally. He actually has that posted either on griffingBrock.com on his site, and I believe also his YouTube page. He actually has a 1 hour step-by-step process of how he goes to produce these bulbs, the vacuums that are required, the procedure for evacuating and everything. What else? Since I've also been trying, since I got back, not only to get the results, but trying to measure some of the effects using a phosphor screen, one of those X-ray screens. So, of course, I got to break into photography and film developing, which has been a fun endeavor by itself. But I don't really have any other things besides showing a few pictures. I could hand it off to Adrian if he's got anything going on.
Yes, thank you, Hakasis. I finally had a chance now properly to get back to the golden ratio discharge experiments. There have been a number of things going on for a while, but I haven't really had a chance since mid last year to look at the new developments, and I finally got my hands on a high-speed camera, which I've been looking around for a while. It's 1,000 frames per second, digital high quality. So I'm planning to take some slow motion, or quite a few slow motion pictures of the development of the discharge. If that's successful, I'll definitely be showing that as part of my presentation at the conference. I think is the presentation that I'm doing, Aaron, is that still on the Saturday?
I believe so.
So I'll include that as part of the presentation that I do then. That's actually going to be quite interesting, because this is something that Eric and I have talked about a number of times now, is actually looking at how those things grow. So how does the streamer grow from the source, and how does it progress into from a primary tendril to a secondary tendril to a tertiary tendril, and the dynamics like the ones that rotate around each other. There is a lot of fascinating things to be learned about how this discharge is working when we get into the realm of high speed. Even if I can, but it requires professional grade equipment at the moment. It would be good to go up to 10,000 frames per second, but I'm going to start at 1,000 frames per second, as that's what I have available to me right now, and we'll see where we get to with that. So that's kind of work just pending now. The other part is the demonstration that I want to give at ESTC is going to be far more comprehensive than last year. I want to cover a range of different frequencies with a range of different coils, and that also needs a more flexible and more powerful tube section of the generator. So I'm just designing that at the moment, and I should be able. I'm planning to, if all works out with that, I'm planning to bring that with me, and I will combine that with the equipment that we donated to ESTC last year. So AM Innovations donated the golden ratio discharge equipment to ESTC for future experiments and development. And this will be something that will work alongside that equipment. So it will still use the same power supply that's there. And when I'm there with Aaron and Eric in April, then I'll look to do a few modifications on that power supply as well, in preparation for July. But the tube will be more powerful. It's somewhat more flexible at driving a different range of coils. And that will demonstrate that if the demonstration works as I intend, it should show the transition of a discharge, what you would normally expect to get for a discharge from a vacuum tube Tesla coil system to a golden ratio discharge. So I'm going to be going in a lot more detail in both the presentation and the experiment about how do you generate the golden ratio discharge, what are the key characteristics which lead to this phenomena, and trying to dig down a little bit in terms of, well, what does that mean? I mean, what fundamental principles are we getting a look at with this type of discharge? So that's my main work at the moment. I have a number of other experiments going on. I haven't done anything more with the telluric at the moment. I still need to construct the 3-coil receiver because I want to repeat some of the telluric experiments that I did last year and the year before with a 3-coil system, and that is still pending. I doubt that I will get to that before the conference, especially with the month in the US as well in April. Other experiments. The other thing is that I also, it's one of those things, but it seems to go in waves, but I've had a number of key pieces of equipment break down in my lab, so I've also been doing a bit of repairing. I don't like it when equipment breaks down. I like to repair it so it's working again. So I've been, and it's also quite fun. It's quite fun repairing stuff. So I've been doing a little bit of that, and I also still got more of that to do, but I want to see the equipment pile going down rather than going up in terms of pieces of equipment that need repairing. So those are the main things. Over the next month, mainly, I will do mostly golden ratio discharge. I want to have things well prepared ahead as much as I can for the conference before coming to the US in April. So that's from me. Hakasis, do you want me to pass back to you for so you can show some pictures? Or
Yeah, go ahead, Eric.
Did you end up with any of the pictures of the recent cable TV shack effort?
No, Justin did not have the cable for your camera for me to download any pictures, and he said he would send me some.
Well, there's a couple more ideas I have about the April episode.
Yeah, go for it.
One is in the last demonstration of the Colorado Spring model, there were some modifications that had to be made to one of the secondary coils to stop arcing. I think that was only done to one phase, and one phase is left undone.
yeah, that's right, Eric. Yeah, I did the transmitter, but not the receive coil.
Yeah, so basically we need to finish that. It's not good to have something half done. And then I think trying not to distract too much from the primary objective, the thing should be presentable at the conference on some level, mostly on a signal level. And the other thing is the quarter wave network to go between the radio frequency power amplifier and the Bolita style Tesla transformer. So that'll be kind of a mathematical network analyzer, impedance versus admittance and all that kind of stuff. So I'm hoping that by the time of the conference, we can get the flame speaker going again with about 3 times the power. But the first order of business is to finally wrap up the modulator bay, because it's 99% finished, and get that thing so that it produces some kind of output, even though there's not a lot that can be done with it right now, because we don't have a trump motor to run with it. We don't have a transmitter to modulate. We don't have any hydrogen cells to fool around with electrolysis. But at any rate, it is possible to demonstrate it lighting up light bulbs, or, in some oscilloscope presentations and what have you, and maybe get into some of the design. So we'll see. It's all a matter of how smoothly things flow and how much help. And then I will be back up there in June with the hope that we can get the flame speaker and the RF, the audio modulated RF thing wrapped up if possible.
Okay.
And then, of course, I have to quantify my presentation, which is turning up to be quite a stack of drawings. I didn't really expect, so I just completed 5 drawings this morning. And it's going to definitely get 2 to 4 hours.
Why does it always, things seem very simple until you actually look into them?
Well, I never even really expected this, but what was happening is right now I'm kind of suspending any further work into advanced mathematics, or like with the heavy side stuff and all that, and because I don't think there's really that many people that are interested in the exotic theory. And it's very difficult. It's a lot of work, and I'm kind of QRU on it, as the ham radios people say. But what I regard as important now is electrical engineering has become completely lost. And so I'm concentrating on the polyphase and the analysis of the polyphase and the harmonics. And so the last presentation I gave on this subject, my intent was to the next book that gets written is that. So I started on a chapter 1, which did not really exist in the presentation. And then it continued to expand, and then things were discovered, and then it continued to expand even more, and more things were discovered until eventually it accelerated into, well, why not do a complete Fortescue analysis of four phases, something that's absolutely never been done before. And what's interesting about four phases is it matches the arch form of alternating current itself. So by using the Fortescue analysis, a lot of interesting things could be discovered by applying it to four-phase resonant circuits and the energy exchanges between capacitors and coils and other things that no one's ever touched upon before. So now I'm all jazzed up into it, and then finding the perfect piece of music. It's now I've become, you might say, somewhat obsessed with it. So basically, this whole process is basically 4 hours a day, 7 days a week, so many days a month, so many months a year. This is a continued process that's been going on for years. So it's not just some idle little thing. I mean, you're talking about man hours involved here, that the thousands and tens of thousands and what have you. So that being said, and then Griffin and I are the audio amplifier project is coming up. Once he's done with the radiant tube, we're going to get into that, and then the earth signal thing, so that he can get some of his earth signal receiving and seismic forecasting together. And then we're going to be looking towards making commercial amplifiers available, if possible, and also the something that ever since I held a monopolar Rife tube in my hands in Rife's defunct laboratory in San Diego, I've always been wanting to produce the 1A21 beam tube, which Griffin has almost completely perfected. And once the 1A21A comes out, that will be commercially available for any number of experiments. So that's quite exciting that that's finally happened, because I've really been
Oh, you should see it. It's beautiful.
trying to get that going for years and years and years now, and nobody's interested. Everybody flakes. And so we got there. And then the next step, something that I'm really quite excited about, but the limited amount of money, the limited amount of space, and limited amount of manpower, we just can't keep loading ourselves up with more and more projects. But the disruptive discharge exciter for the vacuum tube needs to be really advanced and get away from this, funky spark gap stuff, and not having any control over the oscillatory impulse polarity and what have you. So Griffin is making steps towards the construction of the original 30 kilocycle push-pull coil that Tesla used in his early presentations, which immediately made him world famous. And then using a pair of hydrogen thyrotrons rather than spark gaps and all that fooling around to do the disruptive discharge. And this will turn out to be an absolutely fascinating setup, but it's a whole nother project, and we can't start another project right now until we finish the ones that started, and et cetera, et cetera, et cetera. But it's in the primordial phases of development. So if there was some more people involved and some more money and some more space, we could branch out with this stuff. But basically right now, Griffin and I are the only ones that really are free enough to do this stuff without having to worry about a straight job and all the bad things that come out of that kind of deal that prevent you from doing anything, that actually most people I know are completely disabled because of it. But at any rate, everybody's squeaking their little bit in here and there. So that's that.
Eric,
Yeah.
Aaron, if I could just add something.
Sure. Yeah, go for it.
Eric, this is something that we talked about a number of times, and something you also clarified or brought up in the last live call. But when I was thinking about it afterwards, I was just wanted to ask you to recap a little bit on it. But you've always talked about this challenge of plus 20 dBs. You know, if you can get a transmission over the plus 20 dBs, and I was thinking to myself, well, plus 20 dBs on what? What is your primary vision and goal there?
Okay, well, let's say that we have a conventional HF system.
Mm-hmm.
And that produces a received signal of so many milliwatts. Okay, so we will take that number of milliwatts and we will call that 0 dB.
Mm.
In other words, that's our reference. So let's say it's 1 milliwatt. Okay, well, conveniently, that's 0 dBm.
Mm-hmm.
So if we can come up with some kind of HF system or medium frequency or low frequency system that that is 100 times stronger at the receiving end, let's say 100 milliwatts, that's plus 20 dB. If it's possible to demonstrate that this type of transmission system, which does not involve large antenna arrays, but something, you know, that basically mounts to a utility pole, can provide a 20 dB advantage over larger stuff, which is harder to build, particularly at the lower frequencies where you have to have towers that are like 600 to 1,000 feet high, then I think that would be a successful improvement on these types of radio transmission, which certain entities and agencies and what have you are kind of anticipating and are interested in.
And that system might, for example, use any form of transmission mode. So it might be through the ground, it might be through the air, it might be through whatever, as long as it produces a plus 20 dB.
Right. Well, it's going to be in the how would you say, in the category of the Tesla type of transmission. So basically, the way I'm looking at it now, we're not really getting anywhere. One thing is the lack of a substantial transmitter. It really need about 1,500 watts. Anything less than that, you know, you can't really expect. I have the makings of that kind of stuff here, but unfortunately, my co-worker assistant here nearly died, and now he's off the air, and that's kind of dropped. But I have a 1,500 watt Navy fixed installation transmitter, but it's been badly abused. The Collins that Aaron has came out of that lot, and I think Aaron can provide testimony to what kind of mess that thing was in and what we have to go through. This one's a whole rack of equipment, so basically I'm not really in a position to do it by myself, but I do have the stuff, the power. We did get the 3-phase power going here. That's available now, and
do you feel?
Basically, what I want to do, of course, there's a lot of things I want to do, but I have no money and no help. But what I want to do is set this transmitter up, and then set up the coil and determine the how would you say, the terminal conditions for the coil that are necessary to get this thing going down on the 2 megacycle range and 1,500 watts, and have it go on a regular basis. Now, in the times of day and solar conditions that this 2,000 kilocycle band are functional, you know, in other words, work, well, then how does this thing compare to somebody that has a bigger antenna? It's not going to be any type of magical transmission or what have you, but it's a way to start experimenting. In other words, there'll be a beacon station on the air that sends out a signal regularly with a known amount of power and a known transmission configuration, and then we'll see where it goes from there. So that's kind of how I'm looking with the with that end of it. You know, until there's FCC allocations for other frequencies, there's not a lot can be done on 500 kilocycles or down on 100 kilocycles. And I don't know in today's political environment if it would be possible to get any cooperation out of the FCC at all without the usual, splatter of political, whatever you want to call this stuff we're going through.
And do you feel, Eric, that that system would involve a longitudinal transmission mode, or is that not important in this type of system?
It probably would be a combination of both, but I'm not thinking about that. I just want to make it work. One thing I've discussed in the past, and I think it's a reason why this stuff is not working on these higher frequencies, is the quarter wave criteria is not being met. And that's something we have to experiment with. So basically, this can start with lump components like an analog computer. So the network that needs to be built between the plates of the 4-250 power tubes and the Bolinas transformer, where Aaron's at, will be a quarter wave network. So this will be kind of a first, let's see what we have to go through to meet this criteria. The Colorado Springs thing can be analyzed a little more. There's a lot of capacitive loading in that. Now that capacitive loading reacts to the reactances inside the extra coil, which has its capacitance. So what's the ratio of the capacitance of the mass to the extra coil? So somehow we have to have an optimum terminal capacity at the high end of the coil in order to get this thing to really do what it's supposed to do. And then, of course, we have to have an optimum terminal admittance at the low end of the coil, which here is this, massive tank buried in the ground. In other locations, it could be a well or what have you. So that criteria has to be established, the quarter wave criteria, where the impedance on the low end divided by the admittance on the high end equals the square of the actual transmission impedance of the coil, which as of yet is not mathematically identifiable. So that still needs to be hashed out too. What I'm trying to encourage is to start doing this with lump networks and become familiar and as the terminal capacity grows and the ground admittance, becomes more established, and the ratios is just start to see how well does it get out. It's a big project, so.
Transmission mode might not actually matter at all. It may be more about potential and establishing that potential between those 2 points.
Right.
Holding it.
Yeah, the transmission mode is kind of, it's esoteric. It's occult. We can't really, we can fool around this way and that way. But one thing, now that you brought that up, you in your endeavors, you had found out with certain terminal conditions that the coil, so-called coil, will operate in 2 different modes.
Yes.
Now, that's a function not of the coil, but of its terminal impedances. Because Griffin did experiments against, infinite or zero in terminal impedances, and the double moding went away. So now you have indicated that in one mode, you were able to use some kind of piece of 40 gauge wire, and which should conceivably had a large current flow through it, which would have damaged it or its resistance to any activity, but it did not. Now, so maybe we're not really trying to transmit a regular current from point A to B. Maybe we're trying what I call a J.J. Thomson current, which unfortunately that material that I wrote has not been published yet. So that's another, when you're trying to squeak all this through a 1 millimeter hole to get anything to happen. Griffin has 1,000 pages of my finished translations on Steinmetz and Heaviside and J.J. Thomson and all that. And, he can't do everything to get this stuff published and the money and all that. But a J.J. Thomson current is not a conductive current, it's a capacitive current. And
based on the tubules.
Yeah, and the capacitance between in the molecular dimensions, which is extreme because they're so close.
Mm-hmm.
And there's no voltage breakdown because once the molecules are taken out of the picture and you have the space between the molecules, well, there's nothing there to ionize because there's no molecules. So I actually was able to translate the quagmire of J.J. Thomson in his book, Recent Researches on Electricity and Magnetism, I believe, and got it down. I managed to quantify it. I presented it at the tail end of my Power of the Ether as relates to music and electricity, I believe was the title. It was kind of preliminary material, and I made some mistakes in the presentation, but they're not hard to get around. So this type of current does not generate a magnetic field, and there's no resistance or conductance. It's strictly dielectric. So now John Bedini claims that he had accomplished this early on using some kind of semiconductor translation rather than some kind of electrical field transformation. Now, I don't know whether it's true or not, but
it was witnessed by a lot of people at a audio show.
Okay.
So one of those big famous, probably back in the 80s or something like that. But yeah, hundreds of watts from a amplifier all the way across the convention floor to speakers with full power. And when people thought, and this was like 40 gauge wire or something like that, hundreds and hundreds of watts of audio power. And when he removed the little, whatever you want to call them, at both ends of it, and he plugged the wires straight into the amp and the speaker without his little devices on it, it singed the carpet all the way down across the convention floor to show that there was nothing hidden. And I've only found one website online that has the full article on that. It's kind of hard to find, but it was probably in Las Vegas at one of these big audio conventions or something like that.
So that's basically analogous to what I'm talking about. So now somebody did send me something, and I gave the digital address of it to Griffin, but I haven't heard back on it. And I don't know where that letter is. I hope I didn't lose it. According to this person, there are people in Russia that have managed to achieve this type of current flow around 30 kilocycles, and have found that it completely neutralizes the resistance or conductance aspect of electricity going either through the ground or through wires or what have you. I wrote that person back, seeing if they could send me actual copies of this stuff, because I have a very restricted way that I use this computer to keep the little demons and nemis out of it. And I do not go to links. I do not go to websites. And even this is not permitted, but I have to do it because I only use the computer as a television, nothing else. So hopefully that information can be dug up, and there might be some revealing stuff there that would make it easier to accomplish this on a radio engineering level. I don't know, but it sounds legit.
So just to clarify, Eric, if I may, this this vision and challenge that you're talking about, plus 20 dBs up on an HF system, this is something that I understand that you and Bruce have experienced before. So it is practically possible.
Well, I did it in Bolinas, but Bolinas is a very unusual place. That's why Marconi put his station there. It's a geoelectric exaggeration on the planet. But I was successful in getting a signal to blast loud and clear into Los Angeles, which is about 450 miles away. And I had no antenna, and it was on 7 megacycles, which you wouldn't really expect. I had an absolutely fantastic ground system that was electrically directly connected to the San Andreas Fault where it entered the Pacific Ocean. You couldn't ask for anything better than that. So I had a 1/4 acre ground system consisting of 24 ground rods and a bunch of bronze wire connecting it all together. Everything was basically soldered, so there wasn't any possibility of any semiconductor action to generate any kind of harmonics or intermodulation products. And one thing I discovered here in this particular installation in Bolinas is when receiving AM radio stations out of the ground, there was always 2 stations that came in on one frequency. And what I discovered is that whole ground mass in Bolinas is a giant semiconductor. And what it was doing is was intermodulating the AM radio stations and causing them to appear on frequencies that they were not transmitting on. And I thought that was rather remarkable. But unfortunately, Commonweal had that whole installation bulldozed and everything was destroyed. So that's gone. And there's really nothing to go back to in Bolinas. The whole station's been completely overrun. Massive tragedy, considering that the Marconi and Alexanderson grounds are still buried out there, and including big bronze plates screwed to the rocks out in the Pacific Ocean. The cables back to the Marconi building are gone, but wow, what a place, I'll tell you, but not allowed.
Okay. Hey, it's 1 o'clock. We're an hour into the call. I'd like to show a screenshot of your website so people know where the donation information is. And I got a folder of images that Haka says can kind of go over.
We'll walk through pretty quick. Yeah.
Yeah. And then we can open up for questions here in a few minutes. I'd like to kind of wrap this up maybe in about half an hour or so. We can go a little bit longer if we need to, but so yeah, let me get this thing of pictures up. Can everybody see the images? Okay, I'm just going to go, one to the next, and Haka says can kind of narrate what's going on here.
Yeah. So this is one of the bulbs that Griffin produced recently. I think just in the last week. One of the first official 1A21 Tesla radiant matter prototype bulbs. So the next one past that shows some of the characteristics. So this was Griffin's first, this was a shadowgraph taken at 10 feet with 2 tubes that were inside of a cardboard box against the phosphor film in the background to develop the film. There's no places that develop this stuff directly, so he has to have his own lab. He has to have his own photo set to develop it. Next one. This is the same bulb when it's in operation. You'll notice because of the degree of the vacuum, it has sort of a blue, almost blue-green character sometimes, whereas the lighter vacuum tends to be more purple for the nitrogen. Griffin goes into much more detail on the specifics of exactly how the characters work because he's made dozens, maybe even 100 bulbs over the last couple of years. Keep going. That's nothing fancy. It's just one of the tube sockets that he happened to bang together for the official tube thing. Next one. And I don't know if you can zoom in on that. This was the radiation pattern that he measured with one of the bulbs. I'm not sure exactly which one, but calibrated distance to create a fairly good mock-up of the pattern of the emissions that were coming from the bulb. So they weren't entirely straight out the front. There was also side, and I don't know, it helps us understand what's going on inside it.
Okay. Yeah. Well, it won't let me zoom into it.
That's all good.
Okay.
Next up. So these next couple are some of the ones that were taken from the weekend trip that we had. This was him showing me how he's making some of the bulbs, and one of them, I actually made 2 of them while I was there. So it's really interesting to see the process and the art of heating the glass till it's hot like peanut butter and sticking everything together and getting a vacuum so strong that nothing can seep in. So keep going. This is one of the bulbs that he just made in that weekend that's in operation. You can see it also has that blue characteristic discharge. This is powered by the diathermy machine, and you can also tell by the character of the spark in the corner in the left-hand side the approximate voltage and somewhat current of what's being done there. Next one. This is one of the ones with the phosphor film, and behind it, it's various thicknesses of aluminum, foil and tape, copper foil, copper electrode. And the main goal was to basically try to measure the penetration and absorption ratios. I think it's quite amazing to see in person, the spooky green glow and everything coming from the tube. But yeah, so that's neat. Next one. This was the backside, which gives you a slightly better idea how it was put together and how it was exposed. Yeah, you can kind of see the layers of, I believe I forget exactly, the top layer I believe was different layers of duct tape just to experiment with plastic, and the bottom layers were predominantly layers of foil. So next one. This was one of the ones we attempted to use a cloud chamber experiment because we wanted to try to characterize the emissions to see if a certain pattern could be seen. Due to the purple, you can actually tell this is one of the bad bulbs where the vacuum had partially leaked out. And we were comparing both bulbs to see if we get an effect with one bulb and not the other. So we'll go into more detail later on for that. So next piece. This was the diathermy machine that Griffin uses. I forget the exact number. It's a pretty beefy, I think he said 9 or 10 amps. And I believe it was roughly equivalent to Adrian's, which he has on his website and has much more detailed notes on. But that just gives you an idea of the power source that he's using in the majority of these experiments. So next one. This is one of the horribly crude banged together pictures. This was the disruptive discharge basic spark gap. It was really an intentionally crude test to prove if we could actually get signals, if we could get shadow graph results with the bulb without using the diathermy machine. And while it is very weak, we did able to get something that was measurable. So I have something to work with here at the shop. Next one. This was a slightly very changed version of that. This is a vacuum tube Tesla coil using a 304TL in an Armstrong oscillator configuration. It's using the same secondary, recycling the primary. And we did get something on here too, but it was almost immeasurable even with that equipment. So several hundred watts. I believe we think it's predominantly due to a critical voltage being required. So next one. This is another one with one of the first tests. I just cut a couple of pieces of random, I believe 16th inch copper plate in a just random pattern and taped it to the back of the shadow graph film so you could sort of see the exposure and see how it's blocking the emissions, how the shadow graph thing is produced. So that's also kind of neat. You can see how the pattern, the bulbs has a bit of a green spread where it's more powerful in the front and then tapers off onto the side. This is taken with basically zero range. You can see the little light in the background is from the bulb that's practically touching the film, just far enough so it doesn't arc. Next pic. And here's another one. This was another one of the purple bulbs. So much of the vacuum had leaked out. And we were, among the experiments, it was trying to compare the results with a good bulb and a bad bulb, all other things being equal. So this bulb doesn't produce any emissions on the shadow graph. And this bulb doesn't produce any strays on the Geiger counters. So next pic. Not quite in order, but this was one of the bulbs that Griffin was making on the glass blowing lathe. The first time we had actually met, our initial cooperation was he was helping me make a Tesla coil and I helped him make a glass blowing lathe. So that's actually something I donated to him for his effort. So that's kind of cool. That's it for that. So next one. This is some of the stuff that I've been doing in my shop since we got back a couple weeks ago. Not very good results. I'm basically trying to expose the film and having a hard time getting the critical voltage and currents required, so I might have to do some redesigns. Next one. That's the approximate setup. Again, it's quite crude, but the idea is that if you get something on a crappy setup, you can always improve it and make it better and make it work for real. So once I have something functional, then of course you can do the proper build and use the thick copper straps, use the thick wire, precise tuning, quarter wave antennas. But for now, it's still, kind of cobbled together just to see if you get anything.
I'll just tease you slightly there, Hackersmith. There's still too many crocodile clips in that.
Oh, I know. But see, if I get 0% with the crocodile clips, then I know a decent build will be 10 times better. So 10 times better than 0 is still going to suck. Next one.
So here's my Tesla experiment.
Oh,
it's a Tesla turbine with the 6-inch discs, and Jeremiah Furwerda is the one who did all the CAD design, and we got this together in a full-blown system right now that we're kind of working out some of the bugs. It's the way that we're using this. It's more difficult than it looks, and details to come, but we plan to be demonstrating this at the conference. There's a diametrically magnetized neodymium magnet, 1.5 inch diameter by 1.5 inch long inside this cup. And so we're experimenting with different generator coil configurations that fit around this. And it'll be driven by heat, cold steam, which will come in this way. It'll spiral out this way to a condenser tank, just like last year's conference demo, but this is scaled up quite a bit and a lot more beefier build. And the whole hot cold tank system is under vacuum. And so the water can boil at a lower temperature. It's essentially a drinking bird with a turbine in the neck, but it goes one direction from the hot to the cold instead of back and forth when the head of the drinking bird bobs up and down. It's unidirectionally.
What's the RPM on that kind of turbine?
The ideal speed we're looking at is probably about 35,000 RPM or so. The small one, 3-inch that Jeremiah demonstrated last year, was 3-inch diameter, and those discs were just made out of Lexan. It was just kind of a not very well built, but it proved the point. And that was at the conference, he limited it to about 25,000 RPM just for safety.
Yeah, because when you start getting to larger discs, the centrifugal forces start becoming much more compounded. But then also so does the power. So there's always that balancing act of making it big enough to generate a whole bunch of juice, but not so big that they just wobble and blow themselves apart the first time you spin it.
Right. Plus, ballpark, when you double the diameter, you can roughly cut the RPM in half because you're still getting the same peripheral speed.
Mm-hmm.
And so, but anyway, this will be coming to a conference near you. So, hey, I wanted to show. Go ahead,
Aaron. This looks like a considerable advancement in the engineering. I mean, this looks very.
Oh, absolutely. Yeah, very, very expensive too to do this one-off. Fortunately, we have
stainless steel. Is that stainless steel construction?
No, that's just
aluminum.
Yeah, this is aluminum.
Uh-huh.
The shaft is some type of hardened steel. The discs are FR4 fiberglass discs, and this is brass, I believe, which was welded onto the aluminum here. This is CPVC plastic end caps. This eliminates the whole vacuum box that Jeremiah started with, so that it can seal. If anybody has a source or knows of a reliable company that has rotary vacuum seals that don't even really need to hold up to that much vacuum or pressure, we just need to keep the steam inside here, then we'll be able to couple it to whatever type of generator, motor, water pump, whatever kind of mechanical output that we want. But for now, we have to deal with the magnet inside here to seal it up.
That's a good design, though, because it bypasses the need for handling the vacuum in that way.
Yeah, it'll work really well. If we can get a rotary vacuum seal at some point where people can couple it to whatever they want, that'll be great. But this is what we have for now. So let's see. I want to show Eric's website real quick. Eric's website's not showing?
There you go.
Oh, it is. Okay. So ericpdollar.com. This is Eric's website. Some of these posts are from Griffin's been putting some updates of his experiments on here. There's actually a lot of content in this website. If you go through all the years, going all the way back to 2014, I guess, is blog posts, and there's free papers, free videos and stuff. But what I want to show you here is if you scroll down here in the left column, There is a donate information right here. This is a PO box here in Spokane, Washington. We can accept checks or money orders. It is a 501c3, so it's a charitable nonprofit. Donations are tax deductible. As soon as I get those checks, I sign them and I send them down to the bank in Nevada. There's also the way most people donate is this link right here, which is a PayPal donate link. And when you click on that, you're able to manually type in however much you want to donate to EPD Laboratories, Inc. And it can either be one time, and I believe there's a little checkbox that'll come up. If there's a certain amount that you want to donate every month, you just click recurring and it'll automatically do a donation every month. Again, we do have the conference coming up here in 2023. And yes, to answer your question, Adrian, on Saturday of the conference, Adrian's 4-hour presentation here is going to be the first one in the morning on July 8th. Which will be the golden ratio discharge, and there will be demonstrations included. And this will continue on the same path that he started on last year with the demonstrations of those golden ratio discharges. And then he also has a presentation on Wednesday, which is going to be about an hour and a half. And this is on the Toltec teachings, which he went into on the last call. Is there anything that any of you want to touch on real quick before we maybe open up for questions from everybody who's called in?
Yeah, I got one thing.
Yeah, go for it.
There's a certain persistence in this that of these endeavors that needs to be corrected, but I don't know how because of the mind virus situation. One major problem here is all the Tesla transformers that are being used in what we've seen are all quarter wave, and that's no good. It creates a electromagnetic interference situation where you're transmitting, these waveforms and frequencies. It's illegal to transmit. The other thing is whatever's lost to transmission does not end up in the bulb or the spark. These coils all should be built half wave. There should be a negative end as well as a positive end. They should not be quarter wave unless you are using them specifically for the purpose of transmitting or receiving electric waves. Similarly, the oscillators or amplifiers are all half wave, which is very inefficient and produces a very strong second harmonic component that fights the fundamental, which again robs from the output power, and the power supplies themselves are often half wave too, which is grossly inefficient. They need to be, the oscillators or amplifiers need to be full wave. There needs to be 2 vacuum tubes in push-pull, not one by itself. That way, normally if you had 2 vacuum tubes and you went from 1 tube to 2 tubes in parallel, that would double the power. But if you take the same 2 tubes over the 1 tube and push-pull, you get 3 times the power, and the second harmonic is canceled out. So these modifications really need to be made in all these experiments. But of course, people are not going to want to do that because it costs more money and it's got more parts and all that. But
well, the main one was, the other one was already working. So.
Well, this is something that I fight all the time, and it's one of the reasons why people don't like me. And I've actually determined the more people don't like me, the better off that I am, and definitely moving in the right direction is, and that's what I'm insisted upon here. None of these ham radio hysterical events where you slap everything together in 2 days and then next weekend it all takes a crap or you get in trouble with the authorities. We don't work that way here. And, no half-ass, we'll just set up this little thing because it works. Well, when you do that, then no one's going to ever want to spend the money to do it right. And then something comes along, a lightning storm or what have you, and then the whole thing takes a squat and none of it works, and I have no tolerance for any of that. And that's what caused, one of the main things that causes the conflict I have with humans is this persistence that unfortunately was inoculated into me by the United States Navy and Bell Telephone. And I'm a real asshole when it comes to that kind of stuff. So that's about all I wanted to add. You lost your audio, or I lost mine.
You're on mute, Aaron.
What's that?
Hey, okay, I got it. I see Bruce Gavin is on the call too. Bruce, if there's anything that you want to throw in, go ahead and unmute yourself. If anybody has a question, Adrian, what button or whatever does somebody push if they have a question? It'll give me a little thing that's like they're raising their hand, and I can.
Sure. If you go to reactions, then you can raise hand there.
Under reactions, okay.
Yeah, you go to reactions and it has a button, raise hand.
Okay. So if anybody has any questions, you can raise your
Aaron,
hand.
I could say.
Oh, yeah, go ahead.
If you.
Yeah, go for it. Sure. Yeah, go for it.
Well, I don't know how in the world I follow what Eric just said, but but a couple of points early on. The reference to WWVB. I've been listening to that here for a while. With two receiving devices connected to the ham radio receiver, the overhead antenna, which is a set of crossed inverted V's, 130-foot elements at 100 feet point. I can hear WWVB occasionally and fairly regularly at about an S on the S meter, about an S1. When I switch over to the this wire I have laying on the ground, it's about 1,000-foot long piece of insulated number 12, and it's sampling between two ground points spread 1,000 feet apart. The signal from WWVB goes up to about 10 dB over S9. So there's an enormous difference with the wire laying on the ground. Now, whether it's acting sort of like a beverage type on the ground receiver, or whether it's sampling the signal through the earth, I don't know. But the noise level is horrendous here, down around those frequencies, and I have to use the very narrow bandwidth to receive it. But nevertheless, it's very reliable on the ground wire. The other thing I can mention briefly, it's been stated a couple of times about my historic, so-called historic communication I had with Puerto Rico from my East Coast location here. I'm going to set up a couple of resonant transformers and try to reproduce that, since the anniversary of that is coming up in a few days, and about 8 years ago, actually. So I'm going to set up two identical quarter wave resonant transformers that are about 350 feet apart, connected to their own ground terminal, and so I can switch between the two. And the one will be on the terminal that I used initially. The other one is out in a field which is away from the tower that the first one was adjacent to. So I may try to contact the station that I actually made the contact with, to see if he would be willing to come on the air. And then there's a willing fellow amateur radio operator who's about 50 miles from me, that who is located in very salty marsh area, and he has excellent ground. And we may do some experiments between the two sites, comparing time of day and over the air and through the transmissions through the resonant transformers. So anyway, that's kind of what I'm doing here with my limited time, where I too am entrapped by the work a day and the family tragedies that are going on now and all that stuff. So that's it from behind the lines in Rhode Island.
Thanks, Bruce. Hey, Victor, can I put you on the spot real quick?
Through.
Yeah. So Eric, I just wanted you to meet Victor real quick. He actually lives here in Spokane. He has a long history of radio experience and mathematics. And possibly in April, maybe he can stop by the shop to meet everybody and possibly get in on the action. I know I'd like to have more people in the local area that I know that is working on this stuff. Is there anything you want to say real quick, Victor?
Well, I'm very interested in that fractal work, and I've been following Eric's for years, and I think I may be able to help. I recall him saying something about trying to get his math reduced to logarithms and then based on E, and I have some discoveries in that area that I'd like to share someday. But as far as the work on any of the wiring and coils, I'd love to help any way I can. Since my dog died, I have a lot of free time.
Okay, so Eric and both Adrian will be in Spokane for the entire month of April. And that's when we're going to be working on some of the stuff at my shop, which is it's kind of over by Crestline and Francis.
Okay.
It's just a few blocks from there. So, but just touch base with me maybe at the end of March or whatever, and we'll set up a time when they're there and you can swing by and kind of see what's going on and see if there's something you can jump in on.
Okay. Do you already have the sheet metal and soldering work done that you were looking for?
Yeah, there's oh, you're talking about when I put help wanted deal in the last newsletter. Yeah, I have there's about 4 or 5 people who responded. 4 or 5 people are interested in possibly moving to Spokane to work here with me, but 2 of them I know that I'll be getting back to. So that's still kind of up in the air right now.
Okay. Well, I was
So-
curious about using your tube bender to make a giant mag loop antenna. And helping
Possibly.
you out.
Yeah, we can talk about that.
Okay.
Okay, thanks, Victor. Let's see. I'm not sure how to mute you out, or okay, you're muted out. Okay, anything else, Eric, before I take a question from somebody?
No, I'm done.
Okay, let's see, Zimmer. Go ahead and unmute yourself and say where you're from and address
Yeah.
whoever you want you want to talk to.
Do you hear me okay?
Yeah, fine.
Oh, okay. Well, I have a lot of questions for Eric, but first of all, I'm calling from Italy. So, hi, everybody.
Yeah, welcome to the call.
Yeah. Like I said, I have a lot of questions because I've been following Eric's work for a very long time now, and so right now I'm a bit nervous. Okay, yeah. So I think I'm gonna ask if Eric can actually travel abroad for a series of conferences in Europe, because I might be able to set it up. I'm a researcher with physics background, but I'm also into electrical engineering right now. And yeah, the first question would be if Eric can actually travel abroad. Excuse me for my accent. I lived in California a long time ago, and yeah, my accent is
No, your English is just fine. Do you want to answer that, Eric, about traveling?
I'm not really too keen on that. With the world situation is the way it is today, I do not want to leave my my little hole here in the wild, wild west.
yeah. Yeah, I was expecting such an answer, but
Yeah, you couldn't get me on a commercial aircraft at the point of a gun.
at the point of no, I don't want to get to that point. But what I wanted to say, I guess, is I might be able to give you the spotlight that you deserve on a academic level. I'm not, and this is not a joke. I mean, I have a real face. Hi, everybody.
Gotcha.
So yeah, I've always wondered if you could actually travel in the good old Europe and meet, you know, some of the hated academic guys. I know you despise physicists and all that. I know you know where you stand on certain things, and it's okay. I've been influenced a lot from your work, and you know, it's lately something started to move. I started to move on, and I, you know, I was able to get to very high levels, and I'm gonna give a seminar on nonlinear circuit theory with feedbacks on the reactive fields. So for a very important university, but I'm going to disclose the name of the university, you know, later. Not here. I can't. I cannot do that. But it would be awesome if you could get here. And it would change. I think it would change a lot. You know, like you said, it's now or never. And I'm close to something. I'm close to getting something done, very important, both from the mathematical side and the experimental side. And so it would be.
I think Zimmer, Eric was clear about the fact that he's not getting on a commercial plane, even on the end of a point of a gun. So
yeah, I know, but you know, you know.
So Zimmer, would it be, and if Eric is interested in talking to you about the nonlinear circuit theory and some of the math, are you open to talking to him on the phone about that, Eric?
Well, the way I do it is it's best to write me a letter. And then I can, you know, in my own hole, in my own time, I can sit down and think about it and then respond. That's kind of how I do things.
Okay, so
traveling overseas and all that, I can't, you know, it's, I'm not, that's just not happening. I'm not.
Yeah, I know. I was expecting that answer, but
I mean,
you know,
it's not, you know, if somehow I could just, you know, get on the Star Trek transporter, you know, and immediately materialize the other end, I would just love to go to Italy, or Greece in particular. But
or Germany, or Germany too.
No, that's way too socialized for me. It's too socialized. I have no interest in going to Germany. Greece is more, you know, that's more my kind of people, and it's very maritime orientated, and you know, and I would just love to get down to the whole deck of some big vessel somewhere at the switchboard, and you know, but at any rate. That's not, all of that is not really a good place to go anymore. I like it here in the wild, wild west. If you screw up here, there's all kinds of 1,000-foot deep holes that you can end up in.
No, I've been there. I used to live there for a while, so I know.
Yeah.
I know. Okay. I guess I have a couple of technical questions. I'll limit to one, and then I'll fade away. Could you expand the idea of there being no time surface? Because I heard you once say there's no time surface, and I come from the physics side of things, so that was you know, that was something to hear. Bye, everybody.
Well, basically, and this is kind of, you know, with all my polyphase work and all of that, is it is not really appropriate to represent time with diagrams in space. That's the complication. And that's one of the things in assembling this presentation is how do you present stuff in the dimension of time without involving some kind of spatial representation, which is no good because everything that's there in space is all at the same time. But in polyphase, everything's all happening at a different time. And that's what really makes a lot of the textbooks on polyphase power useless, because they just don't seem to be able to address that complication. And they give you these vector diagrams, and the vector diagrams essentially are meaningless. So I don't know if that kind of answers what you're seeking, but at any rate, to draw something on a sheet of paper and say that represents a process in time has severe limitations.
Yeah, that's, I guess I was thinking of Einstein and all that,
Well, Einstein's best to forget. Don't think.
Yeah, I know.
Don't pay
And
any
I'm
attention
trying
to
to.
Einstein. And anybody that loves Einstein is an idiot. And there's no reason for Einstein. Einstein has provided nothing. All Einstein is an image of how to get nowhere and gain favor in circles that now are out of control, for the lack of a better word, and not getting too deep into the situation, because boy, I could really say some nasty stuff.
Yeah. I like I said, I know you stand where you stand on this, and I'm way more similar to you actually, and the chance of giving a seminar is coming from the engineering world, not from the physics world. The physics, I kind of,
Physics has run itself into a complete dead end. All it is neo-paganism.
Oh, well, I guess there's a lot of more people that want to ask you something, but I could stay here for hours of probably days talking to you. So,
well, the thing is just get into the habit of writing me letters.
Yeah, I'll do. But this month I had to meet a very well. I had to do a lot of work for the university, and I couldn't physically, find the time to write you. But I guess I'll end up asking you if we can build a log periodic antenna equivalent for receiving non-polarized power signals. And this is the end. Thank you, everybody.
Okay.
Okay. Let's see. Helen has a question. If do capacitive currents operate through counter space? And if there is counter space, then should there be counter time?
Yeah, you could say that these currents flow through counter space because they have to flow between points in these intermolecular dimensions, as J.J. Thomson would say. Counter time, I don't know how to say something that could be misconstrued or be totally accurate, but with space, it tends to be how would you say, the normal and the counter are reciprocals, where in time they're more plus and minus rather than being, to the positive exponent or negative exponent. They're either positive or negative in themselves. And so there is that aspect to a counter time would be backwards time, where counter space would be within and normal space would be out. Normal time would be so-called forward, and counter time would be backwards. It actually turns out that time is a backwards phenomena that should be preceded by a negative sign in what we regard as normal, but that could just be a mathematical quirk. But that's the way it works out in all of the electrical engineering stuff. Is when you have a proportionality between space and time, like a velocity or what have you. The time is always a negative value in the derivation.
Okay. Hopefully that answers your question, Helen. Yeah, go for it.
I got one I'd like to relay. This is from somebody else. It's if a plate with a high negative voltage is suddenly grounded, does the sudden change of the dielectric field produce an energy displacement into or out of the ambient medium? And saying it a different way is there a fundamental difference between a positive and negative charge?
Well, there's a big difference, but exactly what that difference is not totally worked out. Protons, electrons, well, those things are all kind of just words. If you have a charged plate and you discharge it, then there's a displacement current of the energy that's stored in the space around the plate will flow through this displacement current through space, and that process will discharge that space. That's what lightning does. Lightning is not really concentrated to the visible arc channel. That's just basically kind of a shadow of the whole process. It's when a lightning discharge occurs, what it is, it's a breakdown in about 1 cubic mile of dielectric conduction, which is literally pulling the clouds and the earth together in a strain. This is one of the things that it's believed that causes the clouds to be flat on the bottom, regardless of the elevation. And that discharge barrels into the lightning strike, so to speak, sideways coming in. And the passage of that current is what's disruptive to a lot of electrical equipment and radio equipment and all that. There doesn't have to be any ionized contact at all. This probably the speed of light, these dielectric lines of force are moving sideways, collapsing into the actual discharge. And then, of course, there's reflected waves that come out electromagnetically from the discharge. And that's what's called the EMP, or electromagnetic pulse. So it's much more complicated than just some kind of spark that jumps from one end to the other. So I think
what he's asking would be, so lightning strike, if I remember correctly, the Earth had a positive charge and the clouds up in the sky had a negative charge, and the arc was discharging that potential. So hypothetically, if we were in Bizarro world and the Earth was at a negative potential and the clouds were at a positive potential, relatively speaking, would that have changed? Would that have a different impact? Or if it was a very, very large gradient or very large potential in the opposite direction? I think that's what they were thinking.
Yeah, that will, because you're dealing with, ions and electrons and what have you, and you're also dealing with an asymmetry and, what projection on the ground is irritating the lightning strike, and what kind of cloud, surface area or projection or what have you, the cathodes and anodes, it's just like in a vacuum tube.
Like you don't really have a lot of anode ray emitters, do you?
Well, both ends essentially are, working together
right
towards the middle, so to speak. But if you have a point, a sharp point, obviously it's going to start spraying, and the lightning's going to appear to come from that.
Okay, so I think they'll be happy with that.
It's been my understanding that the Earth is negative and the sun's positive, but other people seem to have that the other way around. But I could have confused that in my mind somewhere over the decades, but I'm not changing that idea that the sun is not a cathode, it's an anode, and that the Earth has a constant stream of electrons emission, and so the Earth is the cathode. But as far as the relative potentials between Earth and clouds, I think that could possibly go either way, but I can't speak on that with any absolute certainty, so I'm not going to say things that might be incorrect.
Okay, thanks.
Hey, anybody have any other questions? It's 1:45 right now. We should probably get wrapped up here in a few minutes, but I'll take some final questions. Let's see, I do want to, okay, so again, Eric's website, ericpdollar.com. If anybody goes there, just scroll down in the left column. All donations are appreciated. The organization runs solely on donations. There's a mailing address for checks and money orders. And if you scroll down a little bit more, there is a PayPal donate link. This is all applied to all the business going on at the building and the different experiments going on there. I'm going to post again in the chat box here. These are all a bunch of websites here. You got Eric's website. The second one, emediapress.com. That is where all the books and videos are posted. And at the top of that website right now is talking about the conference. The 12th annual Energy Science Technology Conference is going to be July 5th through the 9th here in Spokane, Washington. It'll be at my shop again. And there'll be about 17 presenters or so and maybe around 20 presentations. It's a 5-day jam-packed event. Just about everybody who's talking on the call is going to be presenting on different topics. Tesla related, high voltage related, the golden ratio stuff. There'll be Tesla turbine presentations. There'll be and other ones will be posted as we go along. 1/4 of all the seats are already sold out right now. So if you want to come to the conference and meet everybody in person, right now is the time to get the ticket. Here's a couple conference websites. The Energy Science or EnergyScienceConference.com website. Some of the information is redundant on emediapress.com and that website, but if you go to EnergyScienceConference.com, you can go to the 2023 conference schedule link, and that'll be constantly updated as I go along, verifying different presenters and so forth. And here's Griffin's website, griffingbrock.com. He also accepts donations on there, and you can see with a lot of the photos that Haka says explained, Griffin does put it all into the experiments, and he shares that with everybody in the blog posts. And then am-innovations.com is Dr. Adrian Marsh's website over in the UK, where he has it's a wealth of information on there. A lot of it directly relates to a lot of the stuff that we just went over in this call. Any final comments, Eric, or anything? We can wrap it up if nobody else has any questions. If you do have a question, I guess go to reactions, and then there's a raise hand or whatever, and I can bring you on to ask your question. Otherwise, I guess we can wrap it up. Any final words, Eric?
Well, I did want to point out what's going on with the sun.
Yeah,
So
go for it.
there's a lot of, the BitChute hype up, massive this and that and what have you. None of that's true. The solar cycle has been kind of a dud up until recently. It was predicted to be a complete dud, but it has broken from that. The solar flux has risen to moderate levels. That part of the sun now is the other way, but it should be coming back around here in about another 2 weeks. But one thing in the 45 years that I've been studying this stuff with the initiation by RCA, and almost on a daily basis, is something new is happening. And this is interesting. Some while back, about a couple months ago, the solar flux had been characteristically low, maybe about 130 or something. And then one day it jumped up to like 250, which is like moderately high. I've never really quite seen a transition. And then the next day it went right back down. So I checked different sources for the solar flux. Everybody seemed to agree, and okay, well, that's fine and dandy. Well, about 3 weeks ago, I did this again. And this time the solar flux jumped up to high, like 340. Now, in all the decades that I've been studying this stuff, a solar flux of 340 is a very unusual event. I think the highest I've ever seen is 420. And then it did the same thing. It just next day, it just dropped back down. I think it was like 160 or what have you. So basically, we still got about 2 more years to go before we reach the peak of the cycle. And I'm just wondering if this is going to be a regular, somewhat regular occurrence. The sun may put out levels of solar flux activity that have never been seen before. So this is no longer, in my mind, regarded as a dead cycle, and it's going to be kind of exciting to wait and see what unfolds with the solar cycle when it's at its maximum. But again, I want to point out that all the the Chicken Little stuff on the internet of massive CME, it's not happening. Okay, there's nothing has happened other than these brief outbursts that is out of the ordinary for the solar cycle, particularly compared to when I started my study of the interval between 1978 and 1982, when I was still connected with RCA and had facilities provided to me by Sonoma State College in which to do this. Then there were some serious events. There were things that were remarkable. It blew up the electric utility intertie between Canada and the United States. The images of the sun showed giant standing wave rings occupying about 2/3 of the sun's surface. There were eruptions that actually caused the Earth to wobble on its orbit. And it was lots of fun. And it didn't really, hasn't really happened like that since. And then in the mid-1800s, the mid-19th century, there was a thing called the Carrion event, which is still the biggest outburst of solar activity ever recorded, that just played hell with all the telegraphs, and they really didn't know what was going on then. So at any rate, this cycle is becoming unique. And but thus far, giant this and that and record solar flares, and that's not happening. So, don't pay attention to what you see on the internet. There's something I go to called, I believe it's called spaceweatherlive.com. That's on YouTube. Or no, I think it's its own website. Yeah, it's its own website. And that gives you the actual information and the images of the sun and what have you. And if you want to follow it, I would recommend that, because it's readily available and it's accurate and it's very detailed, and you can form your own picture of what's going on, and not the Chicken Little and the skies falling, which the internet is just saturated with.
So Eric, the flux you're talking about is a 10 point what centimeter flux?
Yeah, so one solar flux unit is 10 to the minus 22 watts per square centimeter at a frequency of 2,800 megacycles, which corresponds to a wavelength of 10.7 centimeters. And the provider of that data is a solar observatory in a place called Pentacon, if I am pronouncing it right, in Canada. And you can get that off of WWV at 18 minutes after the hour, or you can get it off of any, the solar websites that various agencies and universities and what have you might offer. I prefer that spaceweatherlive.com one.
Mm-hmm. I just want to show a picture real quick so people can kind of search it on their own so they see what you mean. 10.7 centimeter solar flux. If you type that in Google or whatever, you'll see a bunch of websites that kind of post these graphs. These numbers right here on the left, is that what you're looking at, Eric, when you're talking about 300, 400 and so forth?
Yeah, no,
would be super high. And
yeah, some of those might be, averaged out. So I don't know.
I think these are years, like year 2000.
Yeah, so
dipped in 9.
These numbers that I'm talking about might be averaged out. I'm not certain. So basically, I just form my own graphs off the readings I get, announcements I get off of WWV usually. And if I miss those, then I get them from the spaceweatherlive.com. They give the solar flux on there. And sometimes WWV's doesn't totally match the one on the website, but they're usually close. What I like about WWV is then I can actually listen to what the ionosphere sounds like and all that. So basically, every morning I do kind of a radio analysis with my car, which is designed to sense all of these things. I think anyone that's seen pictures of my car know, with the antennas and all that. And that gives me a more direct, unfortunately, I do not have an HF facility. I lost that at Landers because I would prefer to go that route with actually have the antennas and derive my own solar flux and have, 24-hour a day signals and what have you. But that is to have your own Navy HF facility, you'd have to build it all over again. So I don't know if I could ever get the money. I've got the equipment. I've got all the equipment, but the logistics of getting the poles up and the wire, I don't know how to.
Now, is this the correct website? Is it spaceweather.com or spaceweatherlive.com?
No, spaceweatherlive.com. Give it a try. That's it.
That's it right there. Okay.
Yeah, that's the one I use.
Okay. All right. Any final words, and we can wrap it up? We're going on 2 hours right now.
I'm done.
Okay.
I think it's
Anything
good.
else, Adrian Hawkins says? It's all good.
Yeah, that's
Okay,
all good,
well-
Karen.
Well, thanks for joining us on the call, everybody. And this, as soon as I can, I'll add some subtitles to this and upload it to YouTube, and then that'll be posted in emediapress.com blog. And then I'll email that out to all the newsletters. I'd recommend everybody goes to, let's see. emediapress.com/energy times, and that's the main newsletter where I put out most of the stuff. There's also a newsletter on Eric Dollard's website, and those newsletters are usually copied to there. And for these calls, I'll announce when they're going to be coming up in the newsletter. And then as we get closer, I mostly just email that out to Eric's list. And do you want to, let's see, this is the 25th. When do you want to do a next call, Eric?
Well, whenever, I guess it's convenient.
Let's see, let me get my calendar here if I can find it. So I don't have anything scheduled on any of the Saturdays coming up in March that I know of. You want to do it in 2 weeks, 3 weeks? You pick
The
it. and we'll-
18th, when the 18th would be 3 weeks, Aaron. That probably is quite good. It gives a chance to do some work.
Okay, let's do it let's do 3 weeks. That's good. That's one rotation of the sun.
All right. 11, 18th. Okay, so March 18th, we'll have the next call. Let's do that noon Pacific time. And I'll send out the registration link for that call. And then there may maybe a reminder or so. So if everybody wants to put that on the calendar, we'll see you there in 3 weeks. Thanks, everybody. And I'll send out a link to YouTube when this is posted on there. And have a good weekend, everybody.
Thank you, Aaron. Thank you, Eric.
Okay,
Okay, take care, everybody.
see you all later.
Bye-bye.